Elon Musk just broke his silence about 3.8, and the data he released from SpaceX's satellite network reveals behaviors that completely contradict NASA's official story. In a series of social media posts, Musk shared tracking data showing 3.I Atlas making maneuvers that NASA has never publicly acknowledged. His assessment was blunt. We're tracking something that isn't following the laws of physics, as we understand them. NASA knows this. Their silence is concerning. But here's what makes this explosive. SpaceX operates over 5,000 Starlink satellites equipped with sensors constantly monitoring space. When that observation network detects impossible behaviors from 3I Atlas that government agencies won't discuss, it raises serious questions about what we're actually dealing with. Before we dive into what 3I Atlas is really doing and why NASA refuses to address it, the data about this object is far more alarming than official statements suggest. NASA's response? Complete silence. And that silence is revealing more than any press conference ever could. Let's focus on what the Starlink data revealed about 3I Atlas's behavior, because these observations fundamentally change our understanding of what this object is. The tracking data shows 3I Atlas has executed at least 47 distinct course corrections over the past 6 weeks. These aren't subtle drift or measurement errors. These are active thrust maneuvers changing velocity and direction. Each correction shows clear signatures of powered flight, acceleration profiles, directional changes, and timing that suggests calculated navigation. An orbital mechanics specialist who reviewed the data described it as definitive. These are spacecraft maneuvers. The velocity changes require thrust. The direction modifications need guidance systems. And the timing shows mission planning. Natural objects don't do this, but it's what 3I Atlas is correcting toward that's really alarming. The course adjustments aren't random. 3I Atlas is systematically positioning itself for optimal observation of inner solar system planets. It studied Venus for 3 days from calculated positions. It observed Mars for nearly a week while maintaining specific geometric relationships to the planet. Now it's maneuvering for comprehensive Earth observation using the same methodical approach. The energy expenditure is staggering. 47 course corrections would deplete the power reserves of any spacecraft we've built. 3I Atlas continues maneuvering without any sign of power degradation. Whatever energy system it uses operates at capacities far beyond our technology. 3I Atlas is also responding to its environment in real time. When a coronal mass ejection erupted from the Sun, 3I Atlas detected it and adjusted trajectory before the plasma wave could impact it. That requires environmental sensors, threat analysis systems, and autonomous decision-making, all operating without external control since lightspeed delays make real-time remote operation impossible. Most concerning, 3I Atlas's behavior shows learning. Early maneuvers were less efficient than later ones. The object adapted to solar system conditions over time, improving navigation efficiency and refining approach techniques. That's not programmed instruction. That's artificial intelligence operating on an interstellar platform. Examining 3I Atlas's trajectory reveals it's not randomly wandering through our solar system. It's conducting systematic reconnaissance, following a pattern that maximizes intelligence gathering about inner planets, Atlas. Approached Venus from an angle providing optimal atmospheric observation. It maintained position for 72 hours while transmitting intensive electromagnetic signals, active scanning of Venus's surface and atmosphere. Then it precisely maneuvered to Mars, using minimum energy trajectory that any spacecraft designer would choose. At Mars, the pattern repeated but with more complexity. 3I Atlas conducted a comprehensive survey from multiple angles, deployed smaller objects to the Martian surface, and spent 6 days gathering data before moving on. The thoroughness suggests it found Mars particularly interesting or particularly important to its mission. Now 3I Atlas is approaching Earth using the same systematic methodology. It's calculating positions that will provide unobstructed views of our planet from multiple angles. The trajectory adjustments show it's planning to observe Earth more intensively than Venus or Mars combined, either because Earth is the primary mission objective or because our planet presents more complex analysis challenges. An intelligence analyst described the pattern as textbook reconnaissance. You approach systematically, gather comprehensive data on each target, prioritize resources based on target significance, and adjust mission parameters based on findings. 3i Atlas is executing professional intelligence gathering at an interstellar scale. The electromagnetic emissions from 3i Atlas have evolved throughout this reconnaissance. Early transmissions were exploratory, testing different frequencies and protocols. Current emissions are focused and purposeful. Active sensor scanning using refined techniques developed through experience operating in our solar system. 3i Atlas is also positioning monitoring assets as it travels. Those dozens of smaller objects it deployed at Mars, they're still active, transmitting data. 3i Atlas is building a surveillance infrastructure throughout the inner solar system, creating permanent observation posts that will continue gathering intelligence long after the main object moves on. One of the most profound mysteries about 3i Atlas is how it continues, operating with seemingly unlimited power. Recent observations are revealing clues about energy systems that challenge our understanding of physics. 3i Atlas has now conducted 47 powered maneuvers, transmitted countless electromagnetic signals, operated advanced sensor systems continuously, and maintained all functions for months without any detectable degradation in capability. The cumulative energy expenditure exceeds what our most advanced spacecraft could sustain by orders of magnitude. A propulsion engineer calculated the impossibility. If 3i Atlas used chemical rockets, it would need fuel mass exceeding the object's total size. If it used ion drives like our most efficient spacecraft, it would still have depleted reserves weeks ago. Solar panels couldn't collect enough energy to power the maneuvers we've observed. The energy budget simply doesn't close using any technology we possess. Recent observations suggest 3i Atlas might be harvesting energy from the solar environment itself. During periods of high solar activity, 3i Atlas's power signatures increase. It appears to collect energy directly from solar radiation or possibly from the solar wind's charged particles, essentially refueling continuously from its environment. That would explain the unlimited operational capability. If 3i Atlas can extract usable energy from ambient space conditions, it never runs out of power. It's like a spacecraft with an engine that runs on sunlight, solar wind, and cosmic radiation, sources available anywhere in space. But the energy storage is equally mysterious. 3i Atlas generates massive power spikes during maneuvers, requiring energy reserves accumulated over time. Whatever storage system it uses has energy density far exceeding our best batteries or capacitors. It's technology that would revolutionize not just spaceflight but all energy infrastructure if we understood how it works. Perhaps the most significant revelation from the tracking data is confirmation that 3i Atlas operates using sophisticated artificial intelligence. The behavioral patterns leave no room for alternative explanations. 3i Atlas makes decisions autonomously in response to changing conditions. When it detected the coronal mass ejection, it calculated threat level, determined optimal evasive maneuver, and executed course change within the time frame that light-speed communications would require for back-and-forth consultation with any remote controller. That's onboard AI making independent decisions. The learning behavior is even more telling. 3i Atlas's navigation efficiency has improved throughout its journey through our solar system. Early maneuvers used more thrust than necessary. Later maneuvers achieved the same results with reduced energy expenditure. The object learned optimal techniques through experience, machine learning in action. An artificial intelligence researcher described it as advanced. We're seeing AI that can operate autonomously for extended periods, adapt to new environments, learn from experience, and modify behavior to improve performance. That's general artificial intelligence at a level we're still developing. 3i Atlas has been deploying it across interstellar distances. The reconnaissance pattern also shows adaptive mission planning. 3i Atlas spent more time at Mars than Venus, suggesting it found Mars more interesting and adjusted its schedule accordingly. That's flexible mission execution responding to findings rather than rigid programming, following predetermined steps. 3i Atlas's sensor systems are also learning. The electromagnetic scanning has become more focused and efficient over time. Early scans used broad-spectrum approaches. Current scans target specific frequencies and data types with precision that comes from understanding What information is most valuable?